tie it all together about what combinations, comb, and permutations can tell us with the concept of probability underneath it. Let's use what we've learned about permutations and combinations to answer each question, and we'll state whether the question uses a permutation or a combination and then calculate the answer. The key thing for a permutation is, does order matter? And if you can separate out that answer to being a yes or a no, then that lets us know whether we're using the NCR for combination or NPR for permutation. Using a standard deck of playing cards, how many different 5-card hands can you deal without replacements? Right? Once you get a card dealt to you, it goes into your hand and you're not going to give it back to the dealer. You're going to hang on to it and hopefully gather 5 cards that are a really good hand. This is a combination. Order does not matter in the order the cards are placed into your hand. So getting an ace first or an ace last doesn't matter. In your hand is a collection where there's an ace in it. So combination, 52 cards in a deck, choosing 5. This is a 52 choose 5 calculation. Now I'm going to write it out, the formula, just so we're still talking the formula, and then I'm just going to ignore that formula and just go to the calculator because NCR in the calculator is so much nicer. 52 factorial over 52 minus 5 factorial times 5 factorial. That's the formula for combinations, but thankfully, fortunately, we have the NCR formula in our calculators. Menu 5.3 does combinations. 52, choose 5. There's, let's see, some zeros. 960. That's a lot of different card arrangements that you can get for a 5-card hand. 2,598,960. Now, what if, different question, mind you, this is the next one in the list. What if we were talking about 3 digits from the numbers 12,378? Well, in this case, because we're talking digits, we're talking numbers, the order matters, and when the order matters, it's a permutation. Our formula for permutation, there are 5 numbers in our 12,378 number. They're 5 digits, and we want to choose, or we want to permute 3 of them. So 5 factorial over 5 minus 3 factorial. 5 factorial is 120. And 5 minus 3 factorial is 2 factorial, so it's 120 divided by 2, aka 60. We could also have gotten that from doing 5 times 4 times 3 times 2 factorial divided by 2 factorial, and the 2's cancel, leaving us with 5 times 4 times 3, 60. How many different ways can you arrange 10 CDs on a shelf? Arrangement, order matters. This is a permutation. Remember, if order matters, we are talking about a permutation. If the order does not matter, then we're talking combination. So we're going to take 10 CDs. We're going to permute them into an arrangement of 10 items. This is really the same as 10 factorial. And 10 factorial from the calculator is a rather large number, so let's go get that calculation. 10, click on the button down here near GP to get the factorial, press enter. 3,628,800 total ways. Let's keep going. Now we're talking a professional basketball team that has 12 members, but only 5 can play at any one time. Does it matter who gets to be like number 1? It does. I mean, if you're number 1, you're probably a point guard, and number 2, you're shooting guard, and number 3 is the forward, and number 4 is the large, whatever, the center, etc. So you have like a reason why your position would be the way that it is. But ultimately, no. If in this question, mathematically, we just want 5 players on the court out of the 12 that are sitting, on the team. So order doesn't matter. It wouldn't make sense to put something like 5, members of the team that don't have handles and put them on the court. That'd be bad. But order doesn't matter, so this is a combination. And we will ignore the coach strategy of making sure your best 5 are on the court at all times. So if order doesn't matter and it's a combination, 12 choose 5. Or another way to write it is 12 choose 5. 5. Or another way to write it is the combination of 12 creating groups of 5. The formula 12 factorial over 7 factorial and 5 factorial. Calculator does the rest. So NCR 12, 5. There are 792 separate combinations of players on the court from a team of 5 basketball players. Or 12, I mean. 5 on the court from a team of 12. Calculate each probability using a standard deck of playing cards. What is the probability that a dealer randomly deals a person a 5-card hand containing an ace, a king, a queen, a jack, and a 10? Well, this is a 52 choose 5 situation, and from up above, I know this is 2,598,960 different combinations of 5-card hands. But in that deck of cards, thank you to the counting principle, there are 4 aces, 4 kings, 4 queens, 4 jacks, and 4 tens, which is 4 to the power of 5. So 4 to the 5th is our number for the top of the probability fraction. What is the probability of getting an ace, king, queen, jack, and 10? That 4 to the 5th power will be divided by 2,598,960. And when all is said and done, there is no math yet that can get this to us. So we're going to go to the calculator for this one. I'm going to go clear this so you can see it directly. I'm going to make the screen be bigger. So here we have the fraction, and I want 4 to the power of 5 on the top, and then I want my NCR, my menu 5, 3, 52 cards, choose 5 cards from the pile. And we wind up with 64 over 162,000. This doesn't help us out. I don't know what this decimal is. So I'll show you how to get a decimal in the calculator. You go Control, Enter. And wow, that's a small decimal. Let's see, move the decimal 2 spaces by multiplying by 100. So then it's 0.0394%. Literally like next to nothing. Okay? So thank you so much for watching. This has been page 875. 876 is the last page of our lesson, and we're going to continue talking about some situations where we need to choose a permutation or a combination and why. So stick around for that last one, and I'll see you in our final lesson 3 episode.